Yep. Yes, ma'am. I'm Dr. Priyank Purohit, Associate Professor in Graphic Rahil University. My area of research is the polymer and its grafting and functionalization. So, in our research group, we are taking the kerosene polymer, which has double sulfated group. As you can see, this is the kerosene polymer. It has a galactose backbone. So our concern is to check the gelling property as well as the inherent biological property of this carrageenan. Carrageenan is an important polymer which have inherent biological property like anti-tumor activity and other. So first we discussed about the gelling property. So it is generally it is with the potassium ion as a marine source. So whenever it was ionized in the form, it get converted into the two phases. One is the one polymer phase, the second phase is second polymer phase, which is based on the orientation of the this bond. If you can see, this is the conformation of this. So it was concluded from our group that if we are adding this in cold water, it was getting this shape. There's a helical shape. And whenever it was in hot water, it was in coiled shape. So we discussed, we analyzed this through the energy calculation study. So we found that it is the more stable one. The energy is, this conformer is more stable because of this ionic staggered form. In another case, it was in staggered form. So it is not that much stable. So in whenever the kerosene was added in the water, the ionic form was in gel form because it is the stable and it form HL. As I discussed, this is the gel phase. Whenever we added some amount of heat, the conformational percentage changes from this to this form, this sulfated form. So it was in that case, it was forming gel. In the in that case, it was forming solution phase because in the it was converting to the more energy conformer. It is because of this linkage conformation. It was then we replaced, our group replaced this potassium ion with calcium ion. So we checked that calcium ion has a different capacity. We tried to maintain the distance between calcium and potassium. We saw that the calcium has less size, it means smaller size, and the bond distance is to 2.4 angstrom, which shows that it has more bond strength. Then in the normal water, it was sure that it was not dissociated. Then we again characterize this through the conformational changes. In cold water, it was in solution phase. Why it was so? Because it was not dissociated. And then it was in hot water, it was in dissociated form and it was in solution phase or it was in reverse phase. So we concluded that the ionic form of the this carrageenan is for the gel formation. In this case, if you will see, the conformation was 1C4. It means the 1 is in upper side, 4 in lower side. Wait a minute. Wait a minute. And then we replace this calcium with calcium with barium. In our task, what was the conclusion? That we want to add some hydrophobicity in that polymer. So what we think, we thought that the barium, because barium has more affinity toward the sulfate and it will not dissociate. It was sure because barium sulfate was used as a gravimetric analysis in plenty of times. So the problem of other potassium or calcium and potassium and other sodium also, they are hydrocolloids. The water content, if you see in the IR, we check that OH bonding and OH stretching both were present in that case. It means that the water is present with both in the both of case. So we thought to make a hydrophobic polymer which can be used for the yes, we can say this, for the entrapment of the hydrophobic drugs and other things. And that if you will see, the hydrophobic polymers can go inside the cell, but however hydrophilic, whether potassium, sodium and calcium salt, carrageenan, they cannot go inside the cell, so that they can release the drug. but they cannot go inside the cell. So our concept was to make the gel which has a hydrophobicity log p value more than the calcium and potassium. We found that barium has that kind of capacity. So we tried with barium, and then we saw that it has a distinct character. So then we decide to make the nanoparticles of barium sulfate, because as we know, the barium sulfate is used for the this kind of purpose, uh, X-ray opaque system purpose and other thing. So it was our thought that barium sulfate we can use as a supplement of barium sulfate, because barium sulfate is toxic, and whenever we will add some polymer in barium sulfate, it will be reliable to our body, and it will be that means feasible or to our body to intake, and it has a more lipophilic character. It means it can go inside the cell also. The barium sulfate, the problem was that it was not that much penetratable. So it was decided that barium sulfate, we know that X-ray opaque system, it can be used for. So we tried in that case to mimic that system with the polymer-linked barium sulfate. So we found that whenever we add barium, the water deformation peak was not present in that case. It means water is not there, it means hydrophobicity is there, and everything was similar. In if you see the uh, fingerprint region, in that case it was similar, and the bond length was same. But the problem was that how it was not dissociating. So because of we did the studies regarding the barium, and we published Helian publication in that case, that the specific character of barium and interaction with sulfate is not going to dissociate in that case. In the solid particles, it was completely water free. So what we thought, we checked, and it has the nanoparticles we make through the desolvating agents, and then we found that the molecules has fluorescence activity. It means the polymer is well known for the targeting any tissue, suppose a cancer or other thing. So it means wherever it will go, we can trace that polymer inside the body, and which can release the drug also. So it was our purpose, and it is also a uh, important that this it was showing the X-ray opaque system kind of things. So completely we can use at a diagnostic purpose in that case. So if you will see the microscopic character of this barium as well as another salt, so in that case it was in the needle shape, but whenever we added barium, in that case it was in globule shape, or it shows current it shows the hydrophobicity of that polymer. So we converted this hydrophilicity to the hydrophobicity. So it was because of the cell penetration, and we tried this. We calculated the log k value, log p value, and various other factors. So we found that it was going inside the cell because of the hydrophobicity. Then we checked this nanoparticles through the same image. It was found that 200 to 300 nanoparticles very stable because of the less hydrophobicity. In the earlier case, wherever the hydrocolloids were formed with the nanoparticles, the stability was less. And this process has one more advantage. Whenever we were making the nanoparticles, it was showing a fluorescence, and we were not using any this cross-linking agents, and without heat. So it is also environment benign methods for the barium sulfate linked polymer. And most use of that barium sulfate was to target the tissue cell with the trace of the X-ray as well as the fluorescence light. So as I discussed, this is the fluorescence light of this nanoparticles. It can also visually have nanobarium carrageenan, and difference between normal carrageenan. It has a X-ray resolution system also. We can found, and then we tried this polymer. We this polymer, we if we see that this polymer has more tendency towards the cell. So we surprisingly we found that this cell was very active towards the, if you can see the biological activity of the cell line, it was highly selective towards the lung cancer cell. As you can see, the hope 62 is a lung cancer cell line, and this is the this Yellow line, this is the normal cell. It means it was completely going towards the tumor cell, that is the lung cancer. And then we embedded this gel with the celecoxib, and then we found that it has a synergistic effect. It means the more drug is going towards the cancer cell, and the mechanism was also approved, that the barium prevent the outflux of potassium. So it can, if it is supposed directly to the tumor cell, so it means it will kill the tumor cell, or it is killing. Now in vivo activity is pending, or we are working on that. But so far we know, we get that this selectivity, and it's highly selective towards the cancer cell. The problem of cancer and normal cell is that they have different, they have similar kind of metabolism and other things. So it is very difficult to, but in that case, if we were using this celecoxib, it was directly selecting to the tumor cell. And we checked with the in silico study also. We found that it has a specific interaction in that case. In the peak in the with the we calculated that this, why this barium is more selective towards. We checked that it has a basic nature, and the tumor tissue has acidic nature mostly. In that case, it gets ionized, and it prevents the barium, it prevents the potassium influx. And in an ionized form, it cannot go inside the cell. It can conjugates with the normal cell. So it means in the tumor tissue, it will be ionized, and it will bind as a, it will release the barium ion, and it will uh, prevent the outflux of potassium, and cell death will be there. But in the case of normal cell, it was non-ionized, unionized, so barium will not release in that case. It was kind of the selectivity pattern, why this carrageenan is selective towards the cancer cell. So it was also it was done by the MD study also. We tried to simulate the cell tumor cell enzymes and the molecules both simultaneously for the 100 nanosecond. We found our great results. Our purpose was to take the drug to the target site. We have a carrier now, polymer, and then polymer is directly selective. It means the drug, it will, whatever the drug we will embed in that case, it will go to the tumor cell and selectively increase. So these results are very fine, and then we can trace through the X-ray also, and then fluorescence light also. This was our concern of this proposal. So in this case, we concluded that the barium sulfate linked polymer can be used as a, if the nano size is there, it means it will require less quantity, because carrageenan, if you will take the carrageenan in more quantity, it will create a inflammation and other problems. So better to reduce the amount through the nanoparticles. And tissue nano size is there, it means absorption will be more, solubility in water is less. In that case, it means non-polar, it will go inside the, and biocompatible polymer is linked with the barium, so it means reduced risk of allergic. The body does not want any foreign material to get inside. So if the polymer or polymer kind of which is familiar to the body will go with the barium sulfate, then it will be not allergic or biocompatible, that we can say that. High water solubility, log p value is more, or cancer selectivity. As you can see, this image is clearly showing the selectivity towards the lung cancer cell. It is similar to the celecoxib. Its action was similar to the celecoxib drug. We analyzed this, and we interrupted the drug inside the polymer also. So it was our task to get the polymer linked barium sulfate for the X-ray imaging as well as the drug interpret through the drug diagnostic purpose. So thank you.
Hello everybody, myself Dr. Priyanka Singh. I am working as an associate professor in NIMS University, Rajasthan. And my topic of invited talk is the valorization of the dried flowers of the medicinal plant into the natural dye. As we all know, for the textile industry, we are using the synthetic dye. but these synthetic dye have the toxic chemical component. So now we are replacing this synthetic dye with the natural dye. And for the natural dye, generally the plant sources are generally preferred because they are secreting a specific type of the pigment that are associated with the some of the specific inorganic compound. Because of this association, they are easily entrapped across to the fabrics, and so we are going to get a very good fabric dyed fabrics for by using these natural resources. Generally, plant-based products are generally preferred in the current scenario for the natural dye production because they are very eco-friendly, biocompatible, and very safe for the environment also. But the entrapment of this dye with the fabrics are very poor, so we need a specific mordant agent for the binding of, for improving the association of binding of this dye with the cotton fabrics. So in this concern, we have taken the two medicinal plant. One is the Azadirachta indica, that is the neem plant, and second is the Acacia catechu, that is the babur plant. So we have collected the dried flower from both plants, and then we have sterilized and ground into the fine powder. And finally, we have prepared the different types of the solvent extract in the water, ethanol, acetone, methanol by varying their concentration 2% to 10%. Then with the help of the Soxhlet apparatus, we have extracted the specific dye, and further we have concentrated and dried in the rotavacuum evaporator, and then we have estimated the phytochemical screening testing to estimate the bioactive component present in the flower extract. So in the neem flower extract, after the performing the biochemical test, that is for the phytochemical screening, we can observe the maximum concentration of the carbohydrate, saponin, flavonoid, and alkaloid in case of the ethanolic solvent. In the aqueous solvent, we have got an optimum level of presence of these constituent, but in acetone level, we have got the negative concentration for the amino acid and the very low concentration for the carbohydrate and saponin. So we have selected this ethanolic solvent and aqueous solvent for the further study. Similarly, for the acacia, we have performed the phytochemical screening test, and in this case also for the aqueous solvent, we have got a higher percentage of the this carbohydrate and the flavonoid in compared to the ethanolic solvent. And the acetone also, we have got a very good amount of this bioactive component. So we have selected all these solvent for the antimicrobial activity. As we are using this natural dye for the dye fabrics, so they should have an antimicrobial property against the many microbes. So here we have taken the Pseudomonas aeruginosa, second strain we have taken the E. coli, and third we have taken the Bacillus cereus. In the Pseudomonas aeruginosa, gentamicin, that is the GT, that is the gentamicin as a standard antibiotic we have taken, and in compared to gentamicin, this aqueous extract have showed a very good zone of inhibition in compared to this ethanolic extract and the methanolic extract. Fine. Similarly, for the E. coli, we have got a very great zone of inhibition for the ethanolic extract, that is near about the 15 millimeter in compared to the aqueous extract and the methanolic extract. And for the Bacillus cereus, we have got a very great good zone of inhibition for this aqueous extract. So this shows that in all the aqueous extract, methanolic and the ethanolic, they all have sort of very good zone of inhibition for this extract. It means that whatever the dye we are going to extract from this flower extract, they have the medicinal property. Similarly, for the neem extract, we have got a very good zone of inhibition for the E. coli and the Pseudomonas aeruginosa. So we have taken the both extract for the further study for the synthesis of the natural dye. Now, how we are going to synthesize the natural dye? First, we have collected the dried flower from the neem and the babur plant, and we have made the very fine, ground them into the very fine powder. After that, we have taken because in the aqueous and ethanolic extract, we have got a very good antimicrobial property and very high percentage of the bioactive component. So I have selected the aqueous and the ethanolic extract for the dye preparation. Then we have added a specific type of the mordant, that is in the mordant, two category of the mordant we have used. In first category, we have taken the metal salt, that is mainly the ferrous sulphate and copper sulphate. And for the natural as a biomordant, we have used the green tea for that purpose. So how we have done the mordanting? First, we have treated the dye fabrics with a specific dye. After that, we have added this mordant and then incubate the fabrics for at a 50 degrees Celsius for 1 hour. And after that, we have observed the color variation in the cotton fabrics in compared to the plain fabrics. So in this slide, we have found in the theoretically we have estimated कि when the dye is going to be entrapped with the entrapped with this cotton fabrics, then they are generally associated with the amine or carboxyl group that is present in the polymeric unit of the cellulosic fiber in case cellulosic unit in terms of in this cotton fibers. Okay. So this dye is going to be interactive with the amine and COH. So in the plain fabrics, we can see a white fabrics we have taken, but when we are treating it with the acacia category, that is only with the bubble extract we have added, then we have we can see a very specific light brown color. But when we have added the mordant, that the copper sulphate with this acacia, then the color is going to be varied. This color variation is mainly due to the binding, due to the improving the binding of this dye with the specific cotton fiber across the amine and COH unit. And because of that only color variation is going to be observed. In case of the iron sulfate, we are going to observe the blackish color. That is mainly because of the presence of this mordant. Fine. Similarly, for the green tea, first we have treated the dye fabrics with the green tea only. Not we have added any acacia and anything else. In the green tea, we have observed a very light brown color for that. But when we have used the extract containing the babur with this green tea, then color we have got a very good color of the dark brown color. Similar finding we have seen, we have got for the neem extract also. In the neem extract also, after treating the cotton fabrics with the neem and copper sulfate, we are going to obtain a very gray color of the color. So similar, the color variation is mainly due to the use of the specific mordant, which are going to be improve the association of this dye with the cotton fabrics across the that amine or carboxyl group present at the polymeric unit. So now, on the basis of this, the stability of this green tea, we have mainly found a very good stability of this green, this acacia category that is the associated with this green tea across the dye fabric. This dye fabric has found a very good stability in compared to other biomodels. So we have selected this as a dyed cotton fabric for the further study. Similar study we have obtained for this as a deductor. So we have selected this neem extract with this biomordant and acacia category with this biomordant for the further study. Then we have studied the effect of different temperature on this dyed cotton fabrics, and we have after the 1 hour incubation at the different temperature varying from the 50 to 100 degrees Celsius. For the Azadirata case, we have seen a very similar type of the color intensity for up to the 100 degrees Celsius. Similar finding we have seen for the acacia, that is for the 100 degrees Celsius. This shows that this green tea as a biomordant associated with this dye extract have shown a very good stability and with the color intensity also. So this green tea can be used as a best biomodern system for the developing of our natural dye. Similarly, we have studied the light fastness tested in presence of the natural sunlight, and in presence of natural sunlight after incubating our dye fabrics up to the 72 hours, we have found a very little color variations for the 72 hours. Color intensity is almost same. So we have found that the maximum color stability we have found up to the 4 hours. So this is the optimum period for which we can dry this cotton fabric in the sunlight. And similarly for the detergent solution, we have performed the test, and in the detergent, we have taken the different solution of this detergent up to the 1 to 10%. We have got the optimum result for the 1% of the detergent solution. So on the basis of our finding, we have selected this neem and the acacia, that is associated with the green tea with the across the fabrics for the further study. For the functional group analysis, we have studied the FTIR spectrum analysis. And in the plain fabrics, we have got a optimum peak around the 3331 that show the presence of the hydroxyl group. And we have also obtained a specific peak at the 2920 that shows the presence of the CH stretching vibration. Across that, we have found the many group that reflect the CO bonding, CHO bonding, acetone, acetic bonding. Along that, we have got a very particular peak around the 1016, that is 1016, this peaks, and the 1085. This show the presence of the carbon and fluoro compound after across these cotton fabrics. But when we have treated this cotton fabrics after the dyeing with the metal sulphate containing neem extract, we can observe a very sharp peak near about the 1371. Okay, and similarly for the 1371, we have observed the similar peak here also. This shows in the acacia also we have found a specific peak near about the 1370 here and here also. These both functional groups show the presence of the SO stretching. This shows that our dye, our fabrics have been entrapped with the sulfonate group. So this confirms the entrapment of the sulfonate group from the model to our specific dyed fabric. But the sharp peak at the 1371 we have not observed for the green tea, dyed fabric with the green tea. This shows that in case of the green tea, there is not attachment of any sulfonate group, and other groups are there like a CH stretching, CO and CHO stretching is there. So this also confirm in compared to the plain fabrics, we have obtained a very characteristic change in the functional group, and this confirm that our fabrics had been dyed with this green tea. Then we have
Dr.
performed
Priyanka,
yeah.
Dr. Priyanka, sorry to interrupt you. Please do it as soon as possible because we are
Just
already...
one slide is there, ma'am. This is the last slide.
Sure.
Okay.
Sure.
Then we have performed the same analysis, and for the same analysis, confirm the scaled and fibril structure across it, and this shows the presence of the carbon, that is the scattering of the carbon. Major percentage we have obtained for the carbon and minimum with the chlorine. So this is all about my study, and finally I like to conclude that this natural dye based on the green tea can be used as a low cost effective natural dye for the as a commercial purpose in the textile industry. So this is all about my work. Thank you very much. Hello, ma'am.
Yeah, thank you, ma'am. Thanks a lot.
Any query?
Up to what size you have prepared the samples of different flowers now? Up to what nanometer sizes you have done that?
Actually, here already we have taken the cotton fabrics. Now that is about the 1 to 2 nanometer, 1 to 2 millimeter. We have taken the cotton fabrics, and here same analysis we have only performed the confirmation ki mordant has been entrapped or not.
Okay.
Not any particle size analysis we have not done here, ma'am. Only for the elemental balance.
Okay. So you haven't. Okay. You haven't checked the size variation.
Yeah. Because already we are taking the solid cotton fibers here, no? So we have not checked that.
Okay. Thank you, ma'am. Thanks a lot.
Okay, ma'am. Thank you.
Mr. Madan Lal, please. Mr. Madan Lal.
I think he's not available. I think he is not available right now.
Suma ND, last participant from my side. Suma. Are you there? RP, I guess Suma ji is also not there. So it's the last candidate in my list. Now kindly
Suma
proceed.
ND and Madan Lal, and one more participant was there. What name? Malay, Dr. Malay Kedas.
Yeah, Dr. Malay,
which
Suma
we have skipped.
and Madan Lal. Absent.
Okay.
Yes.
Okay, you have to please mark in the form which we have given to you.
Yes, I'll mark it and will send it to you, ma'am.
Okay, sure. Thank you.
Okay, thank you. I'm logging out. Nice meeting with you all, people. Thank you. Thanks a lot.
Thank you.
Present your work.
Thank you, sir. Good afternoon, sir. Uh, I am Deepa, research scholar, Department of Physics, Sri Vasavi College, Erode, Tamil Nadu. Now we see the topic about an outstanding electrochemical behavior of plasma exposed activated carbon derived by cotton talc. Plasma, plasma is the plasma is a technology is based on the simple physical principle. And then plasma is superior kind of ionized gas, and in general consists of positively charged ions and neutral particles. Neutral particle means atoms, molecules, and radicals. The ionized gas plasma, if it is quasi-neutral and the properties are dominated by electric and magnetic forces. This is next we see that this is a plasma DC glow discharge plasma. Uh, First diagram is the front side of the chamber. Then second diagram is the back side of the plasma chamber. There are two types of plasma: cold plasma and hot plasma. Cold plasma is used in surface modification. Then hot plasma used in industrial applications. The next slide we see that effect of plasma treatment. We use the cold plasma treatment. They change the surface properties or enhance with wettability, adhesion, surface area, and number of pores on the surface. So the establishment of extremely effective energy conversion and storage system is resulting in a need for energy. So mostly carbon materials are more attractive because they are available in different forms of fibers, powders, nanotubes, nanospheres, rich in dimensionality. Now, my present work is cotton talc used as a raw material to prepare the supercapacitor electrode material. Here as prepared activated carbon of cotton talc exposed with DC glow discharge plasma, and the relationship between the surface chemistry characteristics, pore structure of modified activated carbons and capacitance were researched in order to obtain the highest capacitance. This is next we see that synthesis of activated carbons. ACC is activated carbon, cotton talc. We collect the cotton talc and go to the pyrolysis process for 400 degrees Celsius in 1 hour. Then cotton talc again placed into the muffle furnace for 600 degrees Celsius for 30 minutes and give a activated carbon of cotton talc, and this activated carbon grind into nanopowders. This nanopowder placed into the uh, plasma chamber will change the surface of the nanoparticles. And next Next, next we see that is XRD analysis before the plasma treatment and after the plasma treatment. Take the XRD analysis, two theta values of 24 degree and 42 degree, which match to the graphite structure, and the plane values are 002 and 101 planes. On the plasma treated activated carbons has large number of oxygen containing uh, functional units to enhance the specific capacitance. Yeah. So these results see in the FDR analysis. Next, Raman spectroscopy. Raman spectroscopy, we calculate the ratios in before plasma treatment and after the plasma treatment samples. The Ig by Id ratios are 1 and 0.9 respectively. The plasma treated cotton talc was utilized in supercapacitor applications because of its porosity, which is revolved a lot of absorption sites. Next, we see the same analysis. Same episode image of first A is a untreated activated carbon, and DC is the plasma treated activated carbons, and IDAX spectrum of IDAX spectrum C is the IDAX spectrum of untreated activated carbon. Then F is the after the plasma treatment activated carbon. So then in SEM analysis, elemental analysis provide with the micrographs, carbon and oxygen are two main elements as seen in the IDAX spectrum. So in SEM analysis, plasma treatment produces the more number of pores and nanorods structure without changing the already existing pores. So the important characteristics of this method, plasma treatment, produce a energy storage material. Next, we see the CV analysis. CV analysis, these CV analysis performed using a different electrodes, NaOH and KOH, different current rates, as shown in the respective figures. First one is the KOH electrolyte in 1 milliampere. First, A is the CV graph and B is the capacitance. We calculate the capacitance, and C is the capacitive behavior of the cotton talc. Second, D is a 10 milliampere. We give that 3 electrode system, 10 milliampere CV graph. Again, calculate the capacitance. Next is capacitive behavior of the cotton talc carbon, activated carbon. So next, same all the steps follow as this is for KOH electrode with plasma treated, same 1 milliampere, 10 milliampere graphs as follows. First one is a CV graph, and next calculated the capacitance value and the capacitive value. Then D for a 10 milliampere CV graph and capacitance and capacitive behavior of activated carbon. Then next one is a NaOH electrolyte. We see the same CV graph, capacitance, capacitive behavior. Then 10 milliampere capacitance and capacitive behavior of cotton talc activated carbon. Then this
Okay,
is
Dr. Deepa, conclude your work.
yeah,
Yeah,
yes.
conclusion coming. Okay.
So this is a calculated specific capacitance and the capacity contribution of this activated carbon cotton talc. Before the plasma treated, the values of capacitance is low. After the plasma treatment, the values of specific capacitance and capacity contribution is high. For the calculation of this table, then conclusion. So utilizing cotton talc from biomass waste, porous carbon with a superior qualities was synthesized using a sustainable, green, eco-friendly carbon source. Then the morphology and the porous structure of the carbon materials were influenced by the carbonization, temperature, and plasma treatment. Using a 3 electrode setup, the characteristic of activated porous carbon materials were examined. It was discovered the KOH electrolyte at 10 milliampere was the most effective for increasing the specific capacitance of the carbon material. So we can choose the method suitable for this cotton talc activated carbon is supercapacitor applications. That's all, sir.
Okay, thank you.
Myself, Dr. Ranimol Stephen from St. Joseph's College, Devagiri, Calicut, Kerala. So today I'm going to give a presentation on polymer membranes for separation application. I'm talking about the carbon dioxide separation, mainly about my systems and my studies. First, an overview of my presentation, that is, it includes the separation process, merits of membrane separation, historical development of membrane technology, market of membranes and types of membranes used for different purposes, and the membrane modifications, and about my system, that is polyvinyl alcohol and polyethylene oxide based system. It's a nano composite membrane. So in separation process, we know that there are two types of separations, that is conventional mode of separation and membrane separation. So conventional mode, we all know, that is distillation, condensation, absorption on certain surfaces, etc. Using membranes are nowadays widely used for separation applications, for liquid-liquid mixture separation, azeotropic mixture separation, also for gas separation, that is reverse osmosis, nanofiltration, microfiltration, evaporation separation. Evaporation separation is mainly very applicable for the separation of azeotropic mixtures. Then gas separation. Today I'm going to talk about the gas separation, that is different gas, that is nitrogen, oxygen, and carbon dioxide. Three systems we have studied. So before that, few common things about the membrane separation. What are the advantages of conventional separation process and membrane technology? So we know that the conventional separation processes are complicated operations. That is, it is not so economical. Also, there are a lot of environmental concerns, and it is very difficult to separate, especially azeotropic mixtures, using conventional separation methods. But using membrane technology, we can easily separate the azeotropic mixtures. Also, low energy consumption or eco-friendly. This method is very eco-friendly, and most of the membranes, we can, depending on the membranes, we can reuse it, and for different cycles without losing its activity. So historical, when we look on the historical development of membrane technology, earlier days, pig bladder, it's a natural membrane, is used for the separation of water and ethanol. The scientist Jean observed that it is permeable to water than ethanol. So earlier days itself, people find that membranes can be used for separation. Later on, Michel, Fick, and Graham, they found the possibility of mass transfer through polymeric membranes. So Michel used India rubber for the manufacture of balloons, and it is filled with various gases, that is hydrogen and carbon dioxide. After a certain time, he found that carbon dioxide was absorbed by rubber films. That is, the mass transport is possible. He observed that mass transport is possible through these membranes. So carbon dioxide is a plasticizing gas also. Then they formulated the Fick's law, that is Fick's law state that the flux is directly proportional to the gradient. So Graham proposed the solution diffusion mechanism, that is the mass transport through these polymeric membranes, and the permeability coefficient is given by the product of diffusion coefficient and the solubility coefficient. So first used in commercialized membrane is based on cellulose acetate. There is a great demand for the polymeric membranes for the separation of gases. So this estimated to be markets estimated to be $846 million in 2019, and is projected to reach $1,132 million by 2024. So far, till date, this topic is open for the separation of gases, that is polymeric membranes with a good permeability and selectivity. So the industrially used membranes mainly used for the acid gas removal and the nitrogen enrichment, ammonia gas recovery, then syngas ratio adjustment, dehydration, etc. So various membranes can be used for the separation. That is metal and its alloy-based membranes we can use. Then ceramic membranes, zeolites, polymer membranes, and metal organic frameworks, covalent organic frameworks, a blend of these two, metal organic frameworks and a COF we can use. But here I am discussing about the mixed matrix membranes, that is polymeric membranes. These polymers are incorporated with some other nano-sized materials or some other materials in minor quantity, that is mixed matrix membranes. So I'm talking about the mixed matrix membranes. So what are the advantages of these mixed matrix membranes when compared to metal based or zeolite based or ceramics? Metals, in the case of these materials, that is metal based or zeolites or ceramics, so the performance is better. Also, it has very good chemical resistance and thermal stability. But it is difficult to prepare defect-free membranes for the separation of gases. So also not cost-effective. The processing requires for the preparation of these metal membranes or ceramic membranes require high temperature, and the processing is not cost-effective. Also, it is very difficult to prepare defect-free membranes. But the advantages of polymeric membranes are engineering thermoplastic we can use over a wide temperature range. Polymeric membranes, it can be easily processed. Also, we can tune the properties of these membranes by making copolymers of it or by incorporating some foreign materials, that is filler particles, different types of filler particles. We can tune the properties of these polymeric materials. So these membranes should contain some properties, that is, it should contain high flux selectivity, then overcome the permeability selectivity trade-off and the plasticization and membrane fouling. Then it also should possess high mechanical and thermal stability. So these are the challenges also. That is, the membranes, some membranes have good permeability, but the selectivity is poor. So for a good membrane, the permeability, it should have high permeability and selectivity to certain gases. So then only separation of gases is possible. Also, another challenging factor is the membrane fouling, that is entrapment of these particles in the membrane. Then plasticization and aging effects. So carbon dioxide is a plasticizing gas. Its permeability is high in that membrane, but selectivity is less. So also the mechanical stability and thermal stability of these membranes. How can we improve these factors of membranes? By there are different methods for improving these properties, by grafting some lower molecules or cross-linking the polymer chains, then blending with some other chains, or nanoparticle incorporation or chemical reaction on this membrane surface. By incorporating...
Madam, sorry to stop you in between. Can you please go to the result part?
Yes.
Because you have 3 minutes more only.
Okay. So my system is hydrophilic polyvinyl alcohol incorporated with the nano filler. So why I selected this polyvinyl alcohol is it is a semi-crystalline and a glassy polymer. Also low cost is there. Also its film forming property is very good. So, but it is hydrophilic in nature. So, reducing its hydrophilicity by incorporating some nanoparticles. I have used polyhedral oligomeric siliciosane pores. It is pores. It is known as pores. It is a product of hybrid plastics. It has inorganic core and organic functional groups are there. So we can tune the properties of these materials by changing the functional groups. So there are two types of pores molecules, that is caged pores with a caged structure and non-caged structure. I have used caged structure pores, polyethylene glycol functionalized pores for the present study. So we have prepared the samples by simple solution casting method and obtained because of the excellent film forming property of the PVA, we have obtained very good films. And the surface roughness, on incorporating the pores particles, the surface roughness increases. Also, the mechanical properties of the P0 stands for PVA, and it contains different ratio of filler particles, and the mechanical properties increases significantly. So we have studied the gas separation properties. We have obtained the selectivity. Carbon dioxide to oxygen selectivity is 1.97 and 1.86, but for carbon dioxide to nitrogen selectivity, it is higher. Here, octatetramethyl ammonium.
Madam, please conclude.
Okay. So we have obtained a good selectivity for PVA blended with the polyethylene oxide because of the carbon dioxide affinity is higher for either linkage is there. So carbon dioxide affinity is higher for this system. So the selectivity obtained is 38.60. But the target to attain, the target is still the membranes for gas separation is still open. The target is to attain the high selectivity and permeability. So separation of carbon dioxide from other gases is still an unsolved problem because high selectivity and permeability membranes are required for the gas separation. Thank you.
Good evening, everyone. Esteemed sir, my worthy friends, today I'm very glad because I've got a chance to speak before you. I, Dr. Ravi Shankar Rai, Assistant Professor in the Department of Automation and Robotics at Sandeep Institute of Technology and Research Center, Nasik, Maharashtra. Today I'm here to give my invited talk on the topic development of metal-oxide nanostructures interface in basalt fiber reinforced polymer composite for structural applications. This work is basically a combination of the mechanical and the chemical engineers. So before going to the details of the presentation, these are the outlines of the presentation that I'm going to discuss here, which start with the introduction and the zinc oxide and its nanostructure, objectives, materials and methodology, and characterization, and conclude with the future scopes. So before going to the detail, this is the composite materials introduction. Actually, composite materials are the different systems are combined judicially to achieve a system with more useful structural or functional properties non-attainable by any of the constituent alone. So overall, composite materials are an anisotropic and inhomogeneous material, which is a combination of the chemically distinct phase, two or more individual material which must be chemically distinct phase, physically distinct phase, and separated by the distinct interface. And we used to follow the principle of combined action to achieve the more desirable combination of the property. So in this pictorial representation, as you can see that there are various pictures which is showing the different characteristics of the dispersed phase, which is the reinforcement, and as the concentration in this figure, the concentration, size, shape, distribution, and orientation, as any of these parameters we change, we can achieve the different combinations of the properties. So for tailoring the properties of the composite material, we used to modify these 5 factors. So this work is based on the basalt fiber reinforced polymer composite. Basalt fiber is used as a reinforcement, which is just a mineral fiber manufactured from the volcano rocks, and it's a mixture of inorganic oxides such as silica and alumina. It is completely environmental friendly. It has good mechanical property, thermal stability, corrosion resistance, chemical stability, electromagnetic wave permeability, and acoustic and thermal insulation property. And it has a good compatibility with the other materials. So here the matrix materials has been used polymer, which is a bisphenol A epoxy resin. And obviously we have added some hardener along with this bisphenol A epoxy resin. We use epoxy resin because it has ability to have a homopolymerization and has a wide range of co-reactants. And also it has a linkages structure which can combine with the another particles and make a cross-linking structures. So why we are working on the BFRP? Because basalt fiber reinforced polymer composite has a various application. If you go through the this image, you can see that there is a application in the field of aerospace, petroleum, concrete, automobile, composite bar, and road. Since it has a insulating properties also because of the presence of polymer, we can also use it in a different electrical application, that is wind turbine, conductor, cross arms, poles, insulating pull rods, and the blades. So this research statement is after studying the various research paper, it has been found that the people are using different combinations of the reinforcement along with the fiber reinforced polymer composite. So what we are doing, fiber is a primary reinforcement and polymer is a matrix. So we required some kind of secondary reinforcement which must be included inside the system so that it has the adverse set of the properties, or we can get the desired set of the properties. So here we have plan to do some secondary reinforcement which has been done using the zinc oxide nanostructure. So the research statement is completely a development of high performance ZNO nanostructured basalt fiber reinforced polymer composite, in which we have synthesized the ZNO nanostructure on a vegan basalt fiber via hydrothermal method. Morphological studies have been done, effect of synthesis condition has been done, and we have fabricated the sample with the help of vacuum assisted resin transfer molding. And after that, we have analyzed its mechanical characterization using the impact testing and the damage mechanism. So the concept of nanostructured woven basalt fiber reinforced polymer composite is like this. In this image, you can see this is a simple matrix and fiber. This is just a FRP. Suppose you can say fiber reinforced polymer composite. So there are two different methods to add the secondary reinforcement. Initially, people are adding CNT directly into the matrix. So they usually add a CNT particles inside the polymer matrix. Since polymer has a high viscosity and we are mixing it with the help of some hand stirrer or that, so the dispersion of CNT into the entire matrix is not completely favorable. So there are some chances of agglomeration and the no uniform distribution of the CNT inside the matrix. Along with that, the polymer is mixed with the hardener, so it has a certain duration to mix it, because after certain duration it will started making the bond and started solidifying. So we have a limited duration for that. And also if we mix the polymer vigorously, so there are chances of air interact inside the system, so there is a chances of porosity and all. So in another method that we have developed, that there is a grafting of the CNT directly into the fiber. So we have grown the nanostructure on the surface of the woven basalt fiber using the hydrothermal method. So it will increase here. It will increase in this is a plain BFRP composite, and this one is a ZNO nanostructure FRP reinforced polymer composite. So here you can see there is an interfacial interaction between the nanowires along with the polymer and the basalt fibers also. So overall, you can see there is a enhancement of the interfacial characteristics. So due to the increased surface area to volume ratio, structure fiber coated with the ZNO nanostructure is expected to increase the bonding between the fiber and polymer matrix. And grafting nanostructure directly into the fiber is an effective method to improve fiber surface area and mechanical interlocking and local softening also. Along with that, there is a less chances of agglomeration, and the porosity is also minimizes. So after that, there was another mechanism that was found. If there is no nanostructure, so there is a chances of 3 damage mechanism: matrix crack, delamination, and fiber breakage. But due to the addition of the ZNO nanostructure, there are additional damage mechanisms, that is nanorod pull-out, crack deflection, and nanostructures breakage. So overall, the load transfer capacity and stress resistance capacity will be improved. So why we have worked on the zinc oxide and its nanostructure? Zinc oxide is a primary metal oxide nanostructure which has a lack of center of symmetry, volatile structure, large electromechanical coupling, strong piezoelectric effect, pyroelectric effect, and a wide range of band gap and excitant binding energy. And this ZNO nanostructure is already applicable in the different fields like sensors, wastewater treatment, antibacterial application, photocatalyst, fuel cell, and emitters. But this work, I mean, the application of zinc oxide in a mechanical perspective of the any system has been not yet done. So it was just an attempt to apply the zinc oxide nanostructure in the field of the mechanical engineering. Why? Because zinc oxide has another very good property, which is a large growth directions and the large morphological characteristics. So for the synthesis of the nanostructure, we have used different materials, which is woven basalt fiber, and having a different specification which is mentioned here, and some set of the chemicals having an analytical grade. So zinc acetate dihydrate, zinc nitrate hexahydrate, and hexamethyl tetraamine and dimethyl anyl hardener has been used. So for the application of the hydrothermal method, in hydrothermal method, we need to prepare two types of the solution, which is seed solution and growth solution. People usually make only growth solution, but this is a fabric-based growth. So that's why we have added seeding solution, and why we have added, which has been discussed in the further slides. So in the seed solution, we prepared the combination of zinc acetate dihydrate with ethanol and sodium hydroxide with ethanol, and we mix the entire system at 70 degrees Celsius and for 15 to 60 minutes. And we have maintained the pH between 5 to 6. Also, there is a growth solution, which is an equimolar solution of the HMTA and zinc nitrate hexahydrate in distilled water, and maintain pHs of 6 to 8. So preparation of the ZNO nanostructure on woven basalt fiber. Initially, we have just cleaned the sample using ethanol acetone solution and dried in an oven for oven in 90 degrees Celsius for 20 minutes. It is just a surface treatment to clean the sample, because during the production of the fibers or weaving of the fibers, there are some chances of sticking the dirt and dust particles. So after that, the another process is seed treatment. These clean sample has been dipped inside the seed solution for 15 minutes, followed by the removal of the solvent via thermal annealing at 120 degrees Celsius for 15 minutes in a number of repetitive cycles. So 15 minutes of dipping and 15 minutes of drying in a different number of the repetitive cycles. And after that, this seeded sample is directly dipped inside the growth solution and packed it completely and kept inside the hot air oven at 100 degrees Celsius for 6 hours. And after this growth treatment, the sample has been withdrawn from the oven and rinsed them with the deionized water to halt the further growth of the nanostructure, and dried in an ambient condition for 36 hours. So these are three FESM images. The first one is just a seed sample. This sample has been treated only with the seed treatment. And the second sample has been treated with the help of only growth treatment. But the third sample has been treated with the seeding followed by the growth treatment, so that you can completely see that there is a uniform growth of the nanostructure, and the size of the nanostructures and nanorods are completely favorable. So we need to follow for the seeding followed by the growth treatment. So this is the entire layout of the fabrication of ZNO woven basalt fiber epoxy hybrid composite. It started with the surface hydrolysis, seeding, then growth treatment, and after that these samples, I mean 5 set of these samples has been kept layer by layer structure, and we infuse the polymer matrix with the help of vacuum pump. So the entire system has been like a vacuum bagging method. So with the help of these things, after 36 hours or 48 hours of the curing time, the entire sample has been solidified into a BFRP panel. So the morphological and structural characterization has been done. So this is the pictorial representation having the different combination of the molar concentration. The molar concentration of growth solution has been varied from 10 millimole, 30 millimole, 50 millimole, and 70 millimole. As you can see, for lower molar concentration, the uniform growth was not completely done. It was just like a nanoparticles, not like a rod, or hexagonal nanorods are not there. So then wire has been formed, and then there are formation of the hexagonal nanorod, and finally there is a complete hexagonal nanorod has been developed for the 70 millimole. So we have also varied the number of seeding cycle also, and the hours of the growth duration. So there, and after that, we have got the optimized value or a like favorable value of the seeding cycle and the processing time, which is 6 number of seeding cycle and 6 hours of processing time, having a different set of the molar concentration. Overall, 70 millimole concentration is better. And after increasing the 70 millimole concentration, there was a chances of agglomeration just because of the high quantity of the zinc salt inside the solution. After that, we have analyzed it with the help of energy spectroscopy, and it was found that there is an enormous amount of the zinc and oxygen present on the surface, and there were no any foreign element has been seen. And after that, the peak of the structures has been seen with the help of XRD spectra, and it was found that there is a hexagonal nanostructure has been developed having a high intensity peak, and which the entire data has been verified with the help of JCPT's database number 361461. After the preparation of the final sample, the sample has been tested with the help of drop weight impact testing of the ZNO woven basalt fiber epoxy composite. So what we have done, like this is the setup of the drop weight impact tester. So we have kept the sample here, and we have applied the impact load with the help of drop height from the drop height of 0.75 meter and impact velocity of 3.836 meter per second. So the impact energy scale was 0 to 120 joule, and for the different sample, the sample having no nanostructure, then 10 millimole, 30, 50, and 70. It was found that the 70 millimole structure has the highest energy absorption capacity due to the high amount of the nanostructure along with the hexagonal nanostructures interlocking. After that, this is the like failure graph of the absorbed impact energy. So what has been done, as the nanostructure development inside the system increases, the time taken to the failure was also increasing. It was like a brittle fracture, but still there was some time to allocate it. And also we have achieved the high absorption impact energy. And after that, the entire broken sample has been analyzed, and there are some couple of the images which have been mentioned here. So here you can see there are different set of the fracture surface topography. The delamination is there, matrix cracking is there, and the fiber fracture is there. Initially, without nanostructure, these kind of these structures has been seen, and the fiber pull out also. And after that, once the nanostructure has been developed, we can see the debonding of the nanostructure, crack debris, and the ZNO nanostructure pull out, and the ZNO nanostructure debonding. That sticked, these images are a fractured surface images at the interface of the sample. So it was found that there is interfacial ZNO nanostructures are also available after the fabrication and after the fracture of the sample. So it is very better surface topography for the development of the high interfacial interaction. So the stress system characteristics of the sample has been also checked, and it was found that as the ZNO nanostructure increases, the amount of the stress strain characteristics increases, tensile strength increases, elastic modulus increases, and in-plane shear strength is increases. So adding ZNO nanostructure inside the plain basalt fiber reinforced polymer composite is a better way to achieve the high mechanical characteristics. So the result and discussions are like crystalline growth of ZNO nanostructure on woven basalt fiber was developed through hydrothermal technique. In initial process, sticks like nanowire morphology, which was further transformed into the ZNO nanostructure due to the increase in the molar concentration. So overall, hydroxyl ion has a ion concentration plays a vital role for the development of ZNO nanostructure. So overall pH we have maintained between 6 to 8, and it was found that the entire nanostructure has been grown properly along the C-axis, and the growth was explained with the help of FESM, EDS, and XRD spectroscopy. 3 major parameters were considered during the experiment process: the number of seeding cycle, that is 246, and the concentration of growth solution 10, 30, 50, 70, and the length of the hydrothermal treated 246. At the low number of seeding cycle, there were no very low initiation of the seeded particle. That is why the samples did not perform the better results. And along with that, if the length of the hydrothermal treatment is less, that it do not have the enough time to grow properly. So we must have to maintain the number of seeding cycle along with the number of along with the duration of the growth treatment. And after all,
Dr. Ravi, just conclude it.
Yes, sir. There is a significant increase in the impact energy, and we have achieved the highest impact energy of 76% for the sample I4, which is a 70 millimoles concentration sample, and we have also achieved the higher 48.63% increase in tensile strength, 46.44% increase in elastic modulus, and 20% increase in in-plane shear strength. This result suggests that the delamination of composite can be reduced by growth of ZNO because of increase in the effective surface area of the bonding between the matrix and the fiber. So these are the conclusions which has been found that growing the ZNO nanostructure on a woven basalt fiber is a better way to achieve the higher mechanical characteristics, and we can grow it with the help of hydrothermal treatment by varying the different hydrothermal parameters. Future work, since there was only a ZNO nanometer, we can couple it with the help of other carbon material. We can use some dopants or other doping materials, either a metal or non-metal. We can couple with the semiconductors. We can change the amount of doping, some type of coupling we can use. So these are the techniques that can be applicable for the future work to increase the better way of the better combination of the ZNO based woven basalt fiber reinforced polymer composite. And we have also go for the different novel synthesis technique to find out, and some software and simulation technique has been used to analyze the optimum growth parameter, and also we have to do the machinability analysis so that it can be applicable into the different field. So this work is basically for the applicable in the structural application. So for that we used to make a machinability analysis. And these are the references that has been used for the preparation of this presentation. Thank you. Thank you for listening me. Is there any question, please?